Do you think we're missing an opportunity here by not exploring classic antigen vaccines that maybe generate a much more polyclonal response?
Yeah, well, my views on this are very clear, that the genetic vaccines, which is a term I also use, genetic vaccines produce unregulated amount of antigen in the body. You have no idea how much. We know it circulates in blood for several weeks, maybe in microparticles for a lot longer. We know it's represented throughout the body. It's appearing in all sorts of tissues. Post-mortem studies of people dying up post-vaccination are showing the spike protein in the lesions in the blood vessels. So we know this. One of the things I was thinking about also last night was that maybe with the vaccines, because we're expressing unlimited amounts of antigen, maybe we're also swallowing some vaccine, some of the spike proteins, and that's affecting tolerance. I don't know, but I don't think it's been looked at. But the reality is that we have absolutely no idea how much antigen's in the body, what it's doing to our immune response. And it'll be very, very interesting to see as Novavax and some of these protein-based, antigen-based vaccines, as we start getting experience, are we going to run into the same level of immune non-responsiveness that we're seeing now with all the genetic vaccines? We don't know the answer to that. I don't think it'll probably make too much difference to that, because I think that's, but it might. I'd like to think it might, but I don't think it will.
But if you're giving a protein-based vaccine, you're giving a precisely measured dose of antigen, aren't you?
Tiny little weeny bit of antigen, exactly.
And you know exactly how much, and the body's not going to make more of that antigen.
Exactly, and it's going to be pretty much limited to the lymphoid tissue, although it spreads a bit, but not much. Exactly.
So, as we've said, spike protein has been found in the endothelium of blood vessels.
Exactly.
Does that mean, do you think, that the recipe, if you like, the adenovirus vector or the RNA microparticles got into the blood, migrated into the cellular endothelium, and the vaccine stimulated the protein producing mechanisms in the vascular endothelial cell?
I think that's the logical understanding, but we're at early days. We know so little about these vaccines. I know it's very trendy and whatever, but people forget that when we had the 57 and the 68 flu pandemics, they made traditional vaccines within 5 months. 5 months of those, the appearance of those novel mutants. And so the argument that, we've got big advantage with messenger RNA vaccines, it really doesn't hold as strongly as the big companies would like us believe. I'm very concerned about the genetic vaccines. There's a recent study where they tried to make a flu vaccine with a messenger RNA, which you might have seen, and it was no different in outcome in antibody production than the traditional one. So I think that we really have a lot of work to do if we're going to start immortalizing messenger RNA vaccines in our medical